Good morning. Well, all the brave souls are here, and including me. So I almost got dropped out. I said, okay, we have travel restrictions, blah, blah, blah. And then I said, okay, no, I'm going. And I'm here with you, and thanks for making it up. Okay, so before I, do the action here, I want to have some action from you guys. Just want to gauge what kind of audience I am, talking to. How many are InfoSec guys, right? Sort of like in terms of like blue team guys. Blue team, lots of blue teamers. How many are red team guys? Lots of red teamers. How many are data scientists? Okay, I see. Oh, very few. Okay, so now I know where to pitch. Okay. All right. So my journey is with the data science, machine learning is quite a bit, like 15 years, 20 years kind of thing. PhD and everything there. I'm not going to talk my bio here, but what I'm trying to say is like I've seen the various phases of AI and machine learning evolution in various domains. Infrastructure, mobile, transportation, and my last 5 years have been at cybersecurity. Now, all I want to say to you is, first of all, congratulations on what? You are in a field which is going to be the next 20 years, 50 years, or it's going to be eternal. Because there will be always adversaries, there will be always defenders. So you have chosen an area, you have chosen a field which is going to be in an eternal, and you can keep contributing and keep doing your livelihood as well. So, well, what is this all about? Cybersecurity and the deep learning. Well, it's all about money. 2019, I'm just using some numbers, and I will rush it through. And the game of this talk is like I'm going to give a lots of breadth. If somebody says that he can teach you 40 minutes, deep learning and everything, okay, he's making a joke and it's a scam. It takes years and multiple years of effort. But looking at the audience you have and the hackers, and you are quick learners, I will give you tools, techniques, and the places where to go and place the knowledge and how to navigate. Because in the last 5 years, how I navigated and how I build a product at a Calvio and build the features, I will share that journey through the technical work. And obviously, the work which is all done in the product is not shared here, but I will share the one which is open source. Okay? So let's get started. So it's all started with the ransomware. 2019 was all about that. It was not the nationwide attacks and so on. The multi-million dollars, the ransom demands are increasing. So how do we look at now? So we know that, okay, there are attacks, there are threats. Now, as a blue teamer, can I put my thoughts, more organized way and look at, okay, where are the threats? And, can I focus it what I can detect in my environment? So what I recommend is going to the MITRE ATT&CK matrix, and many of you know that I don't need to, preach this, but make a heat map of that, and then, go from there. Again, there's a wonderful report by CrowdStrike, just came on 2020. I highly recommend to look at. The interesting thing is the attackers are moving more to the lay of the land tools. So it's no longer like downloading the tools and doing something with that. They want to do more the things what you already have. So things like PowerShell, which is already there. So they want to leverage those tools, which is already there on your PC, on your servers. And with those, they want to do the privilege escalation and, catch hold of that and keep being in the enterprise for months. So highly recommend to go and have a look at that report by CrowdStrike. This one is atomic redteam.io. So let's say, you have let me tell you a situation. You are a red teamer, and you are in conversations with multiple vendors, and they come to you and they say that, okay, we pitched AI, deep learning, blah, 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 this and so on, right? So how do you obviously there are a lot of conversations, you try out the product, but here is something cool. You can take the tests which are based on these MITRE attack metrics, and you can run against that particular tool and technique which vendor is claiming. And then you can also sort of evaluate that, how deep it is. So this is now we are coming to the analytics and machine learning part of it. Like in terms of, let's say, the attack matrix, and for a particular technique, you want to focus and you want to build a data solution for that, a deep learning or machine learning, whatever solution for that. Now, can I do that? What data I need? What do I need to collect from my SIM? How can I get that knowledge? So this is one place where car.mitre.org, you can actually focus on what are the data sources for, or how do you detect that particular technique. There are some tricks and techniques. So how would you do that? I highly recommend to go and look at that. I think you guys all know about the information security problem. All I want to say over here is the problem has both breadth and a depth. It's so wide, and there are like 300 plus like a sort of like a subcategories, and like 3,000 vendors and technology providers. They're working in this area. So I don't think I need to go into the breadth of this massive scale. But all I want to say is, in each of that field, we do need to empower with the data science and machine learning. And the basic security controls, whatever your CISO says, that have to be there. But beyond that, we need to look for something more. And that's where the data comes into a play. Okay. All right. It was quick rush through. Now let's slow down a little bit and understand more about data. So, when I started my journey, I came from infrastructure and computer networking, or sort of like application monitoring area and mobile area. And then I come to this security and I say, okay, where is the data? What data we can analyze, and what do I need to do? What are the use cases? So here are some data sources, network logs. I'm pretty sure lots of blue teamers here, they know that. I don't need to, teach and tell more about these. But traditionally, if you look at all the UBA vendors and the SIM vendors, what they are claiming is they have technologies which they can detect anomalies. And so a lot more come into as a part of an anomaly detection. And you will see that unusual volume of network activity and unusual ports, you want to detect those. So endpoint logs, and there are a whole bunch of use cases for that. I'm just quickly going to rush it through and slow down at the place where we come more into action. Action means the code. So, okay, here are authentication logs, AD logs, Active Directory logs. I mean, there are a whole bunch of things you can do with that. I suggest this place, Splunk Security Essentials app. I'm not endorsing any particular product as such. Splunk is, anybody can try out freely. I have spoken at a Splunk conference as well multiple times, and massive audience in their conferences. The product as such is, you can look it up. You might be using it every day as well. But this particular app, I really like it because you have the use cases at one place. There are like 400 odd use cases at one place. And, you have some things that, have some data in your SIM or something comes to you, mind, okay, I need to investigate this. you can actually look it up and say, oh, what do I need to do for my endpoint logs? What are the different use cases? Can I do a threat hunting with that? Can I find it at a one place? This one is one place, and the one which I didn't put it on the web on the slides is the threat hunting, threathunting.net, and just look it up for that. Very interesting, and the places at a one place, all the use cases at a one place. Okay, so what you typically do in a data processing, all the game of the algorithm is not really the king. The king is how do you process the data, where you collect the data. So you have the data, let's say Apache logs or application logs or endpoint logs. You'll be processing in some kind of a log processing tool. Either you have SIM, you will have a Splunk, or you will have some ELK or something, right? But you have to do a log processing, convert that unstructured log into a structured log. Typically, you may have logs which are JSON format or key value pairs or something which is free-flowing natural text, and you have to extract the fields out of it. I think I can take the whole workshop only on talking about that. But I can point you to the sources, to get more deeper into that. And, from some of the free sources are ELK, Splunk. You can, try it out, make your hands dirty. So you convert the data into some some kind of a statistics or some structured form, and then you pose it as an anomaly detection. But wait a minute. Didn't the talk say deep learning? Am I, making this up, or what is going on here? No, I do wanted to talk about that, but before that, I wanted to cover the fundamentals. The fundamentals are the 90% of the problems, not even 90%, 98% of the problems in security data science is still about anomaly detection, because you don't have labels. How would you get a label that, okay, yes, somebody did this foobar attack? Somebody has to detect it first and then label it. Like you can't keep on doing it. There are hundreds of thousands of attacks, and you can't keep chasing the IPs. And you can, and that becomes an independent company altogether. So enough said. Let's come to the deep learning part. So the deep learning, there are places you can go and read. I have, some of the, oh, sorry, what is going on? How far it has been doing like this? Okay. So, I was speaking like this. Okay. So we have, okay, there are some issues over here. I don't see what yeah. Okay, I think there is some delay. So there are different learning paths. I have these slides available. You can look it up. You can follow that. How do you, game up? How do you learn towards data science? What all you need to learn? The basic statistics, the machine learning courses, all the free stuff. And if you want the certification, you can take the certifications from these different companies and all that. But these are like all my findings from years of knowledge. I put it together at one place. It will be available. I'll share the slides. I'll share the code and everything. So you'll have it. So don't worry about that. You can find me also, and then, I can, share a lot more information. This is the learning path for deep learning. I'll just take and get to the actual meat of it. Okay, so let's talk about the use cases for deep learning. Now, enough said. As I said earlier, that most of the problems are posed as anomaly detection, but deep learning needs labels, right? So labels means like you want to say something is a bad URL versus malicious URL versus a benign URL, correct? That's just an example. So that is called a label, right? And in the case of web attacks, you may have different kinds of attacks, and you need to have the labels available. So one of the biggest challenge you have, how do you get the label data? And that's where if you are working in a startup, you have a lot more problems, but you have to probably crank up your own infrastructure to collect the data. And if you are in a big company, you will have access to some data, but again, converting that and adding a labels is a challenge. So what we'll do is we will cover a couple of case studies and see how this deep learning come into an action. So, these are a couple of more examples. I'll just, skip with those. Malware detection, these are another use case. There are companies only doing that, and, they are sold for $1 billion. So, and there's no way I can talk about those in depth in 40 minutes. So let me pick up a couple of case studies and sort of give an intuition, okay? So here is the toll traffic. I mean, everybody knows the toll traffic. This audience does not need an introduction as such, but again, students and a professor at Institute of Cybersecurity, Canadian Institute of Cybersecurity, they put some effort together, got the funding from government, and they did an effort to collect the data. So they did an experiment where they locked down like bunch of students in a lab and say that, okay, you're going to use a Tor and you're going to use, non-Tor, just a regular browser. So, and let's collect the data, and you do all kinds of activities, the chatting and the social network and the browsing and everything, all kinds of activities. And then you label them. So it's a laborious process, but that's how you get the data. And they get the data. If you need the data sets, highly recommend to go there, Canadian Institute for Cybersecurity. They are really a game changer, because before that used to be like the old age, like 20 years old data sets, but at least they have made it like 2 years old. They have collected a whole bunch of data sets. They have a form, you go and, fill that form and, collect it, get the data, and then, get your hands dirty. So this is a data set, and the other data sets are also there for intrusion detection and so on. We will see this particular case study for Tor and non-Tor. As I said, they did a whole bunch of activities and they labeled it, and Tor versus non-Tor. And then, now you solve it as, pose it as a classification problem. Okay, so let's see this in action, okay? So, okay, so what you typically do whenever you get into, this is a Python notebook. I would say these are more like a academic exercise, what I'm showing you. This is not a product. This can't be a product. The product is something which handles massive scale, and it has, everything, so many, I can't keep talking about that. But what I'm trying to say here is this is an academic exercise, which is a stepping stone towards building a product. So what are we doing here? First of all, you have a notebook. In that you get the bunch of imports, whatever libraries you need, typically pandas, some MATLAB plot, some plotting or some SciPy, NumPy, typically all those. Those are your typical imports. There are some things like, there is, somebody has published a package also. You don't need to import 20 of them. You can just import that package and that will be enough. So let's, okay, the second trick. So the second trick here is whenever you get a data, I have assumed that you have converted unstructured to structured form. So now convert into a pandas data frame. Okay. So what you are doing is you are loading that data into a data frame so that you can do your data science or machine learning algorithms you can apply on that. Correct? So in this one, you are you have the data, which is a structured data. It has source port, destination port, protocol, flow duration, and so on, like some 20 such attributes, okay? And you have, so this is a data frame described. This is basically telling you that, tell me what all data fields I have and what is my summary of each field. So it is telling you the mean, standard deviation, and so on. Now this is the very much like the very, very nitty-gritty first step. Don't even talk about deep learning. Okay, we will come to that deep learning, but before that, you have to look at your data. Make a friend with that. Become a buddy with that, buddy with your data, what all you are collecting. Because I have seen the problem that I was banging up my head and against some issues. Oh, am I fitting some RNN wrong, or what am I doing? I'm applying everything correct, and then also my results are coming bizarre. The random predictions were random. It turns out the problem was actually in the data, how I was feeding the data. And many times we don't even, we missed out to spend time on the data side. So we spend time on data, we look at, okay, the data looks like this, so we normalize it, okay? Because it may have outliers, right? The basics, these are the basic foundations. Even if you apply deep learning, they are still valid. People may say that, okay, no, you apply deep learning and you say that, okay, all the feature engineering is taken care by the deep learning. In cybersecurity, I disagree with you. I would still say that you still need to do some feature engineering, some data processing to understand what is the problem, how your data is, and what data collection, what are the different attributes you got, and what's the spread of that. So in this particular case, we see that, the max, if you see, they are all varying and everything. So we need to normalize the data. Once you have normalized the data, this is all looks good between 0, 1, and now it is ready to be processed. Now I can take it to the next thing in my data processing. And what is the next thing? Is converting into training and test data. Okay. Now here, there are a lot of sampling techniques. You have less data for your malicious URLs, or you have 0, 1 class. So for one of the class, you have very less data. So you have a skewed data. So you may need to use some stratified sampling or some other techniques to make out that you can sample more from a different class and so on. So by the way, don't worry, I may be, talking a lot more things. And if you are not familiar with those jargon, those words, it's okay. It's perfectly fine. It is more like motivation for you to go and pick it up and learn. So what I'm trying to say here is, the foundation for machine learning here is that you assume that there are two distributions, the training and the test. Now, one of the biggest problems I see in a cybersecurity is many times you see the attacks which you have never seen, right? And so you may not even have a training data for that. So all you can say is that you should have a pipeline to collect the data, gather the label, and feed it to the machine learning classifier so that it shows up in the next time. Or you keep in your classifier, you make it enough robust so that even if you live with some false positives, then you'll be able to detect that. So it's the challenge between, the detection, misdetection, and the false positives. So, okay, what we are doing here, we have the data, we already normalized. We get the training data and the test data. Okay, and it's basically telling you what's my size of the training data and test data and so on. Then, if we need to apply some class weights to take care of the skewness in the data, we can do, you have to do that. I mean, to improve the accuracies and improve the classification, the classifier results. So you apply, okay, this is a traditional machine learning. We are coming to the deep learning part as well. So this is a logistic regression. Apply the base methods first so that you know the label field, you know the data. This is, I always do it. Go with the basics. So apply the naive Bayes, apply the logistic regression, no matter what. And then, you say that, okay, now I come to the neural network part of it. So in this one, we are, using a Keras abstracts what you're calling from TensorFlow, and then you can easily construct your neural network in just few lines of code. So you import the the Keras and TensorFlow, and you're making a sequential model here, basically a feed-forward neural network. And all it has is you specify where is your input matrix, what's the activation you are using, and how many hidden layers you got. And what's your output layer. You just tell that, and you tell what's your loss function and activation, and bingo, you are basically done. This is your first neural network. It takes roughly an hour, okay, if just to pull together this one. But what is an effort needed is before that, all the getting the data and then processing that, that is where most effort is needed. So you get your model. I'm going to do the fit. Fit means you are training the model and learning all the parameters. So let me give an intuition, because I think many of you guys are from, missing what I'm trying to say here. So this is a neural network picture. I should have shown this earlier as well, but here it is. You have an input layer, output layer, some magic in between. What all it is. Basically, the neurons in our brain, they get fired, right? So it is inspired from that is the neural networks, all the bingo you learned, right? What all we are doing that with that code, that line of, the few lines of code there, we are learning the structure. We are learning this network structure, and not network structure, the parameters of that network structure. That's all you are doing. And you have bunch of weights for each of these interactions between the layers. You are actually learning them. And how you're learning them? Because you know the output layer. At the output layer, what is my output? Because you have set aside the training data and the test data. In the training data, you know what is my Tor traffic and what is my non-Tor traffic, right? So if you know that part, so that means you're telling the machine that, okay, here is my data, the traffic data looks like when the Tor traffic is there, when there is a non-Tor traffic. So now with this, you started your weights, but these weights will get updated and learned because you have given the labels. You know the labels. So you know the label, you know the prediction, and you compute the error, and you compute the loss function value and do the back propagation. So in a net sense, all you are doing is, it's a bunch of matrix operations. In those matrix operations, that's all it is. You have a calculus matrix operations, and you are updating those weights and coming up with this beautiful neural network which can do the prediction. So in this case, it is going to predict that what is my Tor traffic, what is my non-Tor traffic. And now let's say you predicted that somebody come and ask you that, hey, how much confidence do you have that this machine learning model is good and it will work in the wild? So you need to compute some statistics, right? So you compute the performance metrics, precision recall, and F1 score, and so on, right? With this, here, the exact numbers doesn't matter. What matters is that you have prepared a pipeline to quickly create a model and now you can experiment with that. Okay. So now something which, I will talk about, how do I take this academic exercise and convert into a product? First of all, the Tor non-Tor traffic may not be the actual problem in your, company or your thing, right? You may have something else. So find out where is that data set, what is that data set, what all attributes are there, get familiar with that, and then if it is already structured, unstructured, convert into a structured, get into a pandas data frame, understand, visualize that data, and now build your data pipeline. And now after that, okay, that becomes a product? Not really. Or that becomes a solution? Not really. You need to see how it will be operationalized in the workflow of the IR guy or in your day-to-day workflow. So enough said. Let's pick up some more case studies and more action. So we took this one and let's take another one. The one of the case studies, which is all of you guys know, is CNC detection, right? Malwares talks to their command center, so we want to detect that. We're gonna apply the LSTM neural network for that, and if I talk about the LSTM, then it will become a lot more. I would need a lot more time only for that. So let me give you a sort of intuition behind it. See, what we did earlier in the feed-forward neural network, there we didn't take into account the history of it. Whatever, like a sequence. If you have a sequence or a history, you want to see, okay, what all happened like 2 days ago or 3 days ago. You want to use that knowledge. You want to use that knowledge into your network model. That's where the recurrent neural network comes into a picture, and the long, short time memory neural network comes into a picture. There are a whole bunch of videos on YouTube. You can look it up, and they will explain you a lot more better. But what I want to give you a tool and technique, how do I apply it for a small problem in cybersecurity? So let's talk about that, because I want to spend more time on that. So, all right, let's come to the action here. So we have bad domains, malicious domain, and the benign domains, okay? Again, the same problem, how do I get the data? Well, for this one, fortunately, there are a whole bunch of data sources available. Alexa, top million, and then you look it up. There are good data sources available on the on Kaggle as well. So you can start from there. So you got your data, and all you're doing is, let's start with the pipeline. So what we will do here, okay. Yep, let's start here. So we have a bunch of imports, typical pandas, NumPy, Keras, scikit-learn, and so on. You have those imports, those libraries, I'm calling it. Now, you may say that, okay, will I be just calling them all the time, or not really, right? As when we are starting, we are doing it. But in the real world, in your product, you may need to code up some of these things from scratch as well. But many of these startups, I have seen that they are built on a top of this, and they're just calling these libraries, and they're calling the functions within them as an API. But they formulate for their own use case. That is where they bring the novelty, and they solve the customer problem, and they solve the real world problem. So here, what we are doing here is that we got the input data. We have the label available. We have the normal and benign, malicious and benign. The both classes are there and the associated labels are there. So this is what it is shown over here. You may read it up, load it up from a CSV. Typically, this is not how it goes in the enterprise. You may have the data in SIM. You may be calling it using a REST API. Or it's like, or you have a data lake. You may have taken just a sort of like a sample of it in a CSV, and then you are loading it up. So that's what I'm doing here. In this particular case, I have the data in CSV, so I'm just loading it in Pandas data frame. I concatenate, bring the class 0, class 1 together. And again, what all you do, you understand the data, what all it is, and you look at the data. And next, since I know, okay, what's my distribution of the data, based on that, you use some kind of sampling technique, stratified sampling technique. In this particular case, we are using that. And you have the data, you construct your training data and test data. If you just do a one kind of like 70-30 training testing and then go ahead with that, that will, be not a robust, and it will not be the accuracies, you can't trust them. So you need to do some kind of enfold. You have to do cross validations. Those are all basics. Okay. So these are all basics, which, is being sort of, in this particular case, it has been taken care by stratified shuffle split. So you got the training data, test data. Obviously, you had, since in this particular data set, what you have is not really the numbers, right? You have the URLs, right? So how do I process that? I have two ways of doing that. The one is like the traditional NLP techniques. You construct the bigrams, trigrams, and then construct the features and give it to the classifier. Or the another one is you represent each character as an embedding and then you process it, okay? So I have both, so I can give you an intuition so that, you can, it makes some sense. So in this particular case, what we are doing is like this google.co.in, right? We drop the in, we only keep the subdomain because that's just a noise. And then you construct the bigrams and trigrams. So it shows you the bigrams and trigrams here. This is just an example for this google.com here. And then you work with these features. So these becomes your features. And then you say, okay, you do compute like some TF-IDFs. You compute the term frequency and inverse document frequency, and that becomes a feature to the classifier. So let's get to the other part where I was applying the LSTM. In this particular case, what we are doing is we are converting, we are representing these domains and each character in that into as an embedding. Now, what that means is you're representing each data sample, okay, in a higher dimension, and then as a vector. So for an example, let's say you have, name Satnam, okay? So S, you take it and then you represent in a one hot encoding and you say A to Z, if I represent as in a vector. So wherever I get S, that becomes 1 and rest all places will be 0, 0, 0. So you represent that. And now A, you have, let's say, this 26 character vector. In that vector, the 1 will come only when you have A there, and rest all will be 0. And the same thing when you have the T, then where the T comes, then you have 1 there, rest all will be 0. So all you have done is you are trying to capture, you are representing the data into high dimension, and then with that representation, you are capturing a lot more context around it. So instead of, in this particular case, when you convert the bigrams and trigrams, your context is only this much, like only just like a 2 bigram, right? GOOG, right? You may say that, Satnam, why 2? Why not 5? Why not 7? Why not 10? It increases the complexity, right? That is what you are doing with the embedding. You are converting as in a vector and you are getting a lot more context, what all character coming along with it, and that you are representing it. If you have that conversion done, the word embedding, and now you give it to the classifier, the accuracies will improve dramatically. So this is all, like all the action you see on the deep learning is because of these representations, the richer representation. So let's come to the representation part. You have the word embedding, you represented that, and this is where I was talking about. You have an embedding you have done, and now you give it to the LSTM layer, and you don't want to overtrain it, so you have a dropout, and you specify your output layer, and you specify the loss function and the optimizer. Bingo, that becomes your model. So this kind of a model can be built quickly, but obviously the next thing which comes into a part, will this work in a wild or not, right? That is where the real challenge comes. So I take that model, I fit it, I get this model, I fit that model, and then I predict on it, right? That becomes, obviously this one is telling the accuracies here, and here I can tell you, one small example. Let's say you have a test URL and you want to say, whether this one is benign or you are malicious, then this will do a prediction. So now the next thing comes that what happens in the real world. Now I make this model, okay, what you're telling is, okay, I will learn all this and I will learn my LSTM network, I will predict, and I go and put it in the wild in my company. First of all, what do I need to take care of it? First thing, the model versioning. I'm telling you, this is not trivial. What data set you used? Did you have a label for that? I mean, which date the data was, because the data is also getting updated, right? So what day you took that a snapshot? How would you, make that as a part of your process? Then second thing is the model, right? The model which you are updating it, you are maintaining it. Where is your model, where your models are stored? Then the third thing is, not really third, the topmost. Who is orchestrating? Who is orchestrating the model? Who is invoking it? Have we given a REST API interface for the UI layer to invoke it? So you have to make a REST API for that. Where the output gets stored and where you are getting the feedback from the user. Have you taken that into account? These are the things which you need to take into account to make it towards a solution or towards a product. So, okay, so let's get back and see what all we got here. So the next question comes that, I saw there are a lot of red teamers also. There are a lot of red teamers in the room. And so some motivation for them. Any use cases for red team guys? Oh, there are a whole bunch of them. I'm not talking about the ones which are published, like, attacking on the deep learning models where you are confusing the classifier with, okay, there is a stop sign, you put some label, and then the self-driving car will, slow down, or it will think something else. I mean, obviously, those are all the use cases, but I'm talking the ones which within your company, when you are working as a red team guy, What can I do? Many things we can do. Phishing attacks. The phishing attacks can be all automated. So as a red team guy, I can actually write the whole bunch of scripts, collect the data about my company employees, and construct a classifier, which are the candidates which I should send a phishing and which will have a high probability of doing a click. All this can be automated. And that's where the machine learning can be used by the red team guys. There are tools which are doing an automated phishing. SnapR by John Seymour and Philip Tully. There's an interesting project, password guessing. There are password data sets which are available on Kaggle, and we can build deep learning neural network which will generate passwords. So how do I use that one? Well, you need to have a data set which is probably in your company. You have some data set which is contextual to your company. You take that data set and build a classifier which will predict the passwords, and you not to use those passwords, or you can look out for those passwords. So many things are possible. So I think I have talked enough. There are a whole bunch of other, I will skip this one. I will share the code. We have built a password generation classifier for that, and you can use that one too. So okay, I have talked about enough. How do I take prototype to product? What are the challenges? We have fantastic team at Acalvio, and we all have shared to this work. And at Acalvio, we have a product which uses machine learning, AI, and deception to help companies detect the hidden threats in the network. So, okay, I think let me stop here and take the questions. Questions, please. I think I have loaded with a lot of things, please. If you can say your name also, that will be nice.
Yeah, my name is Adil Sheikh. My question is, when we have an unstructured data with large number of entities, how do we find that what is statistically relevant to our research?
I'm sorry, unstructured data?
Unstructured data with large number of columns.
Okay.
How do we find that what is statistically relevant to us?
Very good question. That was a very much in the beginning part of it. Okay, so when you have any unstructured data, that is like 90% of the cases, that's what it is. All the logs are like that. That problem is kind of solved in a sense, like you have to use some kind of a log processing tool. Okay, either you use a paid or a free, whatever, ELK, Splunk, or whichever one, right, or any of the same. You have to convert them into the fields. So you have converted into the structured form now. So you have the field and the values, right? Now you say that, okay, which attribute I need to use? I would use the combination of both the domain knowledge and also the data science. So in data science, something called a feature selection. The feature selection can be done with the various techniques, like information theory based, information gain, and so on. But before that, even I would use the domain knowledge. So for an example, when I was showing the Tor and non-Tor traffic example, does it make sense to put IP addresses as a feature? It does not make sense, right? Because when I take that model and I put it in another enterprise, the IP addresses would be different, right? So it doesn't make sense, right? So that's where the domain knowledge comes into a picture, and the other attributes like the flow duration and so on, right? Those kind of things, I can apply the data science and see whether that attribute is informational or not. And based on that, I can use that model, that particular feature. So it is a combination of both which you have to use. I think there is a question in the end. Or I can take it if we have a time. Okay. So looks like we don't have a time, but I'm here. I'll just step out and then, I'll be happy to take your questions and, interact with you.
Thank you, sir.